Okay, good morning. I hope everybody is doing well today. I know that maybe it wasn't the ideal amount of time to complete everything, but we'll address that in a couple of minutes. Regardless, we have to move on, so we have to start moving on. So go ahead and put your pencil down, pick up your colored pen. Equity bars are in effect today. So let's see how we did with number one. Number one only, I got students. 5, 14, 4, and 21. Student number 5, what do you say?
8x plus 32.
Student number 14, what do you say?
I got 8x plus 32.
Student number 4.
8x plus 32.
Student number 21. The answer that I was looking for was 8x plus 32. Now, number 2 is a new style question that is going to be implemented this year and moving forward. And it's a great style of question, but it changes the way things need to be done. This looks like it's a multiple choice question, but now it's called multiple select. And what that means is there may be more than one right answer, and you have to select all the right answers, otherwise it's not correct. Today is the first time you're seeing it. So try not to think of it in terms of I got it right and I got it wrong. Try to think of it in terms of this is a learning process. Let's see how much I was able to figure out. So even if you did not finish number 2, you should have been able to figure out a few things. So let's see what we figured out. Which of these expressions are linear? I've got student 9, 1, 7, and 2. Student number 9, what do you say? But you should have been able to figure out something. Well, what letter did you get up to? Okay. Student number 1.
Yeah, I got it to be also.
Student number 7. Student number 2.
I got it to be also.
Okay. So I guess the timing just didn't work, and that's okay. But C and E are both linear. The more important thing at this point is to be able to understand what it is I'm asking for. And so we're going to see this type of question a lot moving forward. So I'm asking which of these expressions are linear. If you don't know what the word linear means, then you have no hope of getting this right. So let's start there. What does linear mean? So this is an issue. So if you don't know what linear means, then your notebook is right in front of you. Quickly try to figure it out. But Aaron and Ethan, start us off. Okay. Okay. Both things they said are beautiful. Absolutely. So if we graph a linear equation, it's going to be a straight line. If we look at the expression itself, we will see the highest degree of 1. Highest degree of 1. Could someone say something a little bit different than highest degree of 1? What are we looking for? Natalie?
The
Highest exponent of 1. Well, I'm confused, Mr. Gallant, because I see an exponent of 2, 2, 2, 2, 2, 2, 2, 2, 2, and 2. They all have an exponent of 2, so how could any of them be linear? They must all be quadratic. So, since many of you told me you only got up to part 2b, everyone right now, I want you to figure out C. Give me a thumbs up if you've got it. 1, 2, 3, 4. Okay, another couple of minutes. Another few seconds. All right, so we're going to go Andrew and then Tatiana. Andrew, what does it come out to?
8x minus 10.
What do you think it comes out to?
8x minus 10.
So it comes out to 8x minus 10. How did that happen? How could it possibly be 8x minus 10? There was an x squared there a moment ago. I am so confused. How could that happen? Melinda?
Because we multiply them, both the exponents, they cancel out each
Just the exponents cancel each other
other.
out?
The one with the
Okay.
2.
So let's make sure we're saying things correctly. So here is a great example of gator ball, right? Talked about gator ball. What's this called that I'm demonstrating? What's that called, Milan?
Distributive property.
Okay, so that's one sport. Distributive property's got rules, right? And when we execute the distributive property, we get 12x squared plus 20x minus 16 for here. But here we get minus 12x squared minus 12x plus 6. And so what Melinda is pointing out is that this and this are opposites, and that they will cancel each other out. 20x and negative 12x is 8x. Negative 16 and positive 6 is minus 10. And now it's linear. Now if we were to graph this, as Ethan said, it would form a straight line. A and B, if we graph them, will form a parabola, like that, maybe upside down. That's different. So any questions about that? If you do E, all the variable terms cancel each other out, and you end up with a constant, and that's also linear as well. Any comments, questions about number 2? Any comments, questions about number 1? Ethan? Good. So unfortunately, if you were pulled out of class yesterday, you missed the key parts of this, and that definitely gave you a disadvantage. I guess I was hoping your teammates would help you along. So I am not asking you for the perimeter of the black rectangle. I'm asking you for the perimeter of this red rectangle that you have to add in. So if we find the perimeter of the black rectangle, how would you find that if I wanted the perimeter of the black one? So about 16 of my students should frantically have their hands waving because you were all here yesterday and you can easily tell me. Bontravius? And that's it? That's the perimeter? Okay, so Bontravius is on the right track, but unfortunately he's going to get fired from his job because he's missing a simple idea that perimeter is what? Gloria? Yeah, so what did he miss? Yeah, the two sides. So yeah, that's the right idea, but just because there's nothing written here doesn't mean they're not included. So the perimeter of this photograph is going to be all the way around. But I'm not asking for that. I'm asking for, the perimeter around this rectangle. And so you have to somehow figure out the distance from here to here. What's the distance from there to there? I know of at least 4 people in the room who figured it out. Isabella? 3x plus 10 is the distance. Now, it was 3x plus 7. Where'd you get the 10 from, Isabella? We're adding 1.5 right here because we're increasing that distance and we're increasing this distance 1.5. So that's 1.5 and another 1.5 and the 7. 1.5 1.5 and 7 is 10. Then we have to increase the distance going down the side by 3 as well. We get x plus 6. Now add up all the sides. So again, I apologize if you were pulled out yesterday. I was hoping your teammates would have helped guide you a little bit. Any comments, questions, any follow-ups? Any observations? Good. So, just a reminder that last lesson was part 1. This is part 2, and this is a case where I'm wrapping both of them together and we'll grade it as one large lesson. You already have the homework assignment, and it's going to be the same homework assignment at the end of this. You should have already done some of the homework assignment, and some of it you wouldn't have been able to do. So, we are still multiplying polynomials. That has not changed. Last time we were together, we learned how to do things like we did in the warm-up. Like this, right here. Monomial times a trinomial. We also did monomial times monomial. Today, you're going to learn how to do this. So I don't need you to copy it. This is just a heads up. By the end of today, you should be very familiar with what's going on here. So there are a few new things today, but most of it you already know. So let's talk about what we do know. Multiplying polynomials. Write that down, please. So this is a binomial times a binomial. That we've never done before. We've done monomial times things, but never binomial times binomial. But now I want to change it for a moment. You don't do this, but I'm going to do it up here. So watch carefully. If I took this out and I asked you to just do that, give me a thumbs up if you can do it. Good. Put your thumbs down. If I took out this, and we pretended that that was right over here, and I asked you to do it, give me a thumbs up if you could do that. Some of you say yes, some of you say no. Because all of a sudden the X is there throwing you off. That's fine. Well, what is it an example of? What is it that we're looking at? Okay, don't answer. Don't answer, because I know you. I'm not going to deal with the crickets today. So now let's go back to this. So you should have an idea of how to do that. And now I want to know how to do that. You've got 1 minute with your team, and you come up with some way to do this. Discuss it. See what you can figure out. what'd you come up with? Start with Mark, Vontravius, Aaron. Mark, what did you guys come up with?
We got 8x.
I don't want the answer. I want to know how are we going to do it.
Oh, okay. So we multiplied 2x times 4x and got 8x.
I don't want to know the answer. I want to know how to do it.
Okay, we multiplied 2x times 4x and multiplied positive 3 times negative 1.
Okay? Vontravius?
Multiply 2x times 4x, 2x times negative 1, 3 times 4x, 3 times negative 1.
Okay, Aaron?
Multiply 2x times 4x and 3 times negative 1.
Okay, so you agree with what they had figured out. Okay, so let me go back. Okay? So let me erase this again. And I asked you if you knew how to do that. Give me a thumbs up again if you can do that. Okay, now change your hand position and tell, using your fingers, show me how many multiplications are going to be done for just that. How many multiplications? Hold up the number of fingers. Yes, of course, it's 2, right? Because what is this an example of? What is that an example of, Angela? That's distributive property. We have 2 multiplications we have to do. Now let me back up. Now I'm going to get rid of this. And we're going to pretend that the 2x is right here. How many multiplications are we going to do for that? Hold up the number of fingers. Some of you not sure. Put your hands down. Well, what is this an example of? Christian? And how many multiplications do we have to do for that? 2. So if there's 2 multiplications here, and there's 2 multiplications there, how many multiplications overall is it going to take to accomplish this? Vontravius knows. 4. Because it's exactly what Vontravius said. It is going to be the 2x here and the 2x here. That's distributive property. And then it's going to be the 3 times the 4x and the 3 times the negative 1. Remember, each arrow, well, I didn't draw arrows, but each line represents a multiplication. So that's 4 of them. So we could do that. I don't want you to write this down, but I want you to look. I could do 2x times 4x, 8x squared. I could do 2x times negative 1, that's negative 2x. I can do 3 times 4x, that's 12x. And 3 times negative 1 is negative 3. And then I can put it all together. Okay? So that's what we're going to be learning how to do. But we're going to frame it around an idea that someone came up with a long time ago because it's memorable and it helps with such a challenging idea. And so this is the new that you're going to learn. It's called FOIL. And I know that FOIL is a product you could buy in the store to wrap up your leftovers at home. But in this case, the word FOIL is serving as an acronym. An acronym is a word where each letter of the word means another word. So technically it's called the FOIL pattern, and we're going to learn it formally right now. But by next time, you'll be saying things like, oh yeah, just FOIL it. FOIL it. It's kind of like Google it. You FOIL it. Okay? So the F stands for first, the O stands for outer, the I stands for inner, and the L stands for last. So you have to learn what each of those means, but once you learn it, you'll remember it, and applying it is not too difficult. One thing I want to make sure we're clear on right now. This only works for 2 binomials. It will not work for any other situation. So I'm going to help using this example. I'm going to label what the F's are. So the F's are the first terms in each binomial. In other words, that's the first term, and that's the first term. 2x is the first term in this binomial. 4x is the first term in this binomial. So the F's are 2x and 4x. So I'm going to put an F here and an F here. And once you have the two letters, it's a multiplication problem. Now, outer comes next, but I'm going to skip over outer and inner, and I'm going to go to last. So if 2x and 4x are the first, what do you think the lasts are? What do you think the lasts are? Shannon? 3 and negative 1. Wouldn't that make logical sense? Any questions so far? Now, outer and inner. Outer means on the outside of the whole thing. So, I didn't mean to do that. If I got rid of this, those are on the outside. Right? If you're looking at the whole thing now, that's on the outside. So those are the outer. So if 2x and negative 1 are the outer, what do you think the inner are going to be? What do you think the inner are going to be? Deja? 3 and 4x. And each pair of letters means a multiplication problem. But this is also an example of gator ball, where we have multiplication and addition going on at the same time, and you have to know the rules for both. Any questions so far? So now that we actually have identified each piece, we can start putting it together. We're not going to do the whole thing, but I'm going to show you what we're going to be doing. We're going to use this as training wheels. We're going to start out writing an F, an O, an I, and an L. And really, it's F's plus O's plus I's plus L's. That's technically what's going on. So we take the F's and multiply them together. So it's going to be 2x times 4x. And then we take the O's and multiply them together. And so that's going to be plus, see the plus? 2x times negative 1 plus the inner 3 times 4x plus the L's, the 3 times the negative 1. So we actually just did distributive property. We just organized it in a nice way. And there is a reason why, and you'll see it in a little while. Any questions on how we did FOIL? So now we're going to use it from beginning to end. Now that we have the basics, let's go ahead. We start with some easier ones and move to more challenging ones. So, we're going to start out with training wheels. When you're ready to take the training wheels off, take them off. Remember that everyone doesn't have to take them off at the same time, and just because the person next to you took off the training wheels doesn't mean you do. You take them off when you're ready. So, here's the training wheels. F, O, I, and L. So let's see who caught on from the previous page. What are the F's in this case? Keops?
The S and the
S times S. Each letter represents a multiplication problem. But then the letters are being added to each other, so we've got plus. Here is the harder one. What are the O's? What are the O's? Christian? Very good. S and negative 2. Plus, what about the inners? Emily? 4 and S. 4 times S. Plus the last, the L's. Sean?
4 negative 2.
4 times negative 2. Very good. Now, we have it set up now we actually have to execute the multiplication. So we have to multiply, 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 multiply. So we basically started out with soccer. Now someone kicked the ball up into the air and someone caught it. Now it's basketball or football. Let's pretend it's basketball. So now we're doing basketball. So now we have to do S times S. What's S times S? Natalie? S squared. Plus, what's S times negative 2, Ethan? Negative 2S. What about 4 times S, Isabella? 4S. And what about, I don't need anybody for that. Negative 8. So we started out with soccer. That's how Gator ball works. Someone kicked the ball up in the air. Someone caught it. Now it's basketball. But then they threw it to one of their teammates. The person took off running. Now it's football. What can you do with those? What is that called? Tatiana? Very good. So Shannon, what can we do with them? Very good. What will we get?
2S.
We get 2s. These are like terms. Combined together, you get 2s. This is still here. We got s squared plus 2s minus 8. And so we just did FOIL, and we just multiplied a binomial times a binomial. Now, I want you to think about something. Right now, we're at the training wheel stage, and we're going step by step. But by next week, you should not be doing this, and most of you will not be doing that either. And so, boy, that looks a lot easier, doesn't it? Compared to all that. So this is for now. As you get confident and you get better, you will start skipping things and doing things mentally. That's assuming that you're getting it right. Anyone have any questions or concerns on part A? Okay, well, we still got training wheels on, so now we're going to do this. Is that a binomial times a binomial, though? Well, if you're having trouble seeing it, I mean, isn't there another way to write something to the second power? What could I write this as, Christian?
X minus 4. X minus 4.
Yeah. This means the base times itself. So we could rewrite this as this. So it is a binomial times a binomial. And so now we're going to use the training wheels. F, O, I, L. What are the first terms in this case? First term, Deja. X times X. Said that perfectly. Plus, what are the outer terms in this case? Outer terms, Milan.
X and the negative.
X times negative 4. And what about the inner terms? Inner. Kianis?
Negative 4 and X.
Negative 4 times X. And the last terms are going to be what, Ethan? Negative 4 times negative 4. Can we just do that mentally right now without even writing down negative 4 times negative 4? It's 16. So we can just go ahead and multiply it right now. So we've got 16. So we just took care of soccer, but now we've got to do basketball, basketball, basketball. We already did one of them. But I'm thinking some of you already did it. Give me a thumbs up if you already did it. Yeah, see, I'm going too slowly for you guys. Deja, tell me all of them. Good. 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 And we already know plus 16. So we did soccer, we did basketball, now we're at football. What can you do with that and that? Aaron?
Combine them.
And what do you get?
-8x.
Very good. X squared minus 8x plus 16. Anyone have any concerns? Any observations? Any thoughts or questions? Very good. Let's see how you do on your own. I've given you 3 of them. I expect high levels of success on A and B, and I expect you to push yourself on part C and do the best that you can. You can do it. I have no doubt that you can do it. You got 3 questions. I'll put 4 minutes. see how we did. My focus is success on A and B, but I would love for there to be some level of success on part C as well. So stay on your toes. Here we go. Part A, I've got students number 14 and 4. Student number 14.
I got, or the answer, right? Or not the answer. Okay. I got a squared minus a minus 12.
Okay, student number 4.
A squared minus a minus
So we have 2 students who agree, and that is the correct answer. Very good. What about part B? I've got student number 1 and student number 21.
I got x squared plus 9x plus 9.
Okay? Student number 21?
x squared minus 6x
So we have a disagreement. I've got student number 2. Can you break the tie?
X squared minus 9x plus 6.
X squared minus 6x plus 9. And part C, I've got student 3 and student 9. Student number 3, what'd you get? Student number 9. Well, it's no different. You just have to know how to multiply a monomial times a monomial.
I got it right, Mr. Gallagher.
Well,
Good. So, I want to talk about part B because 2 out of the 3 students that I called on got it wrong. So, I want to talk about the fact that this really means x minus 3 times x minus 3. First terms, x times x. Outer, x times negative 3. Inner, negative 3 times x. The last, negative 3 times negative 3. And we have a negative 3x and a negative 3x, which comes together as negative 6x. So I can already tell from the responses that there's the confusion between the sports. We've got people using football rules when it's soccer, and so on and so on. So you've got to be careful. Okay? It's going to take some practice. Any comments, questions? So now, that's just part. Now, up a level of complexity. First of all, I want to take care of this, that we would love to use FOIL because it's so easy to remember, but we cannot. FOIL only works when you're multiplying 2 binomials, so it will not work for a binomial times a trinomial. So now we have to go back to really what FOIL is, which is the distributive property. So I want to go way back to the beginning of today's lesson to here. So what do you see represented right here? Deja? Very good. I love the way you said that. So we're doing distributive property twice, but this time, each time you do it, you have to multiply by 3 terms. So it's the x times this, times this, times this, and then the 5 times this, times this, times this. How many multiplications do you have to do total? Hold up the number of fingers to represent the number of multiplications that you have to do. I have some students with hands that are not functioning. Okay, put your hands down. So I want to show you what I did last year. Is I did the first distributive property and I wrote all those here. And then I did the second distributive property and I wrote all those here, and then I just combined like terms. So this is stuff you already know how to do, but there's 2 other ways that we can do it that might make it easier for you. So I'm going to do one quickly because I am a little low on time. So I'm going to do one and I just want you to watch. Just watch, and then I'm going to show you another method that works really well. So it is distributive property. This times that times that. So I'm going to do that first, and I'm going to do it mentally because I'm already ready to do that. I've taken the training wheels off. X times x squared is x to the third. X times 4x is 4x squared. X times negative 6 is negative 6x. So I've done the first distributive property. Don't write this down, just watch. Now, I have to do the second one, which is the negative 5 times here, and times there. But I'm very experienced, so watch what I'm going to do. Negative 5 times x squared is negative 5x squared. Negative 5 times 4x is negative 20x. And negative 5 times negative 6 is positive 30. What did I do? Gloria? Milan, what were you going to say? Yeah, I stacked up the like terms so that, like in elementary school, I could do this and add down. Like terms are now stacked up right there, and I will get the result that I want. Any questions about that? So here's another method that we're going to try, and this time you are going to write it down. Let me get rid of all this. So now what I need you to do is make a table. It's going to be across, I need you to, and you can use the lines on your paper. I need you to draw 1, 2, and then we need 4 columns. So it's going to be like this. It doesn't need to be perfect at all. The binomial, and this works for everything. This works for binomial times binomial times trinomial. It works for everything. Take the binomial and put each term in a box right here. So the x is going to go right here. Negative 5 is going to go right here. Take the trinomial. Each term goes in a box across the top. This box is going to stay empty. So we're going to put the x squared here, the 4x here, and the negative 6 here. Anyone know what we're going to do now? What are we going to do? This goes way back to first, second grade. What are we going to do now? Kianis?
We're gonna multiply x times x to the second in a box that they intersect that, and then the same thing all across, and then the same thing down.
I love how you said that. I love how you said the box where they intersect that. That was great. So this empty box right here is going to be the product of this and this. And this empty box is going to be the product of this and this. It's where they intersect. So she said that beautifully. And so again, I'm ready to do mental math. It's okay if you are or you're not. It doesn't really matter. But I'm going to do x times x squared is x to the third. X times 4x is 4x squared. And x times negative 6 is negative 6x. Now do the next row. Negative 5 times x squared is negative 5x squared. Negative 5 times 4x is negative 20x. And negative 5 times negative 6 is just 30. So the result is not quite the same as what I showed you a moment ago, but look at where the like terms ended up. Like terms right there, and like terms right there. And so all you have to do is combine like terms and put it all together. So we end up with x to the third power. Then we've got a negative 5x squared and a 4x squared. That's negative x squared. Then we have a negative 20x and a negative 6x. That's negative 26x. And then we just have a 30. So So the table helps you stay organized and pay attention to where things are and what's going to get added together. Any comments or questions about that? Nope. I've shown you 3 different ways to do it. One way was just writing them all in a line like I did here, and then you combine like terms. Negative 4x squared, 15x squared gets you 11x squared, and so on. I did the stacking method where I lined up the like terms, or use the table method. It's up to you. Anyone have any questions or concerns? All right, let's see how you do on your own. You got 2 questions. Use whatever method you would like. But make sure you're paying attention to details. Make sure you're paying attention to what rules must be followed at what particular time. Back together as a whole group. Let's see how we did. On part A, I got students 20 and 11. Student number 20, what do you say? Student number 11.
X squared minus x squared minus 6x plus 8.
That is correct. Beautifully done by both of you. And part B, what do you say? I got student 16 and student number 9.
Negative 4x squared plus 3x squared plus 11x minus 4x.
Okay, student number 9.
3x to the third plus 2x to the second plus 5x plus 10.
We're close. Any questions or concerns? You know where you went wrong? Can one of them find it? Can Daniela find it, or Emily? Go ahead, Melinda, what's your question?
I'm asking.
Okay, Aaron, what was your question?
For A, I got negative 7x to the second.
Okay, it's because you ended up with a squared when you shouldn't have. So I'm going to come look at your paper. Okay, so that's a matter of knowing the rules of multiplication versus addition. Okay, I'm going to come look. Leave your paper out. All right, I'm way behind schedule, and that's my fault, not yours. We do have the whole purpose of all this. Now, I have to stop, so I cannot do this with you. But that doesn't mean that when you do your homework, you skip the question that is related to this. It is my expectation is that you will stretch your mind to apply what you've learned at a higher level into real scenarios. Do not skip any questions. So your homework, which you already wrote down last time, is page 355, numbers 1 through 18. But that counts as 20 questions because 2 of them have 2 parts. And you're going to have your chapter 6 test next Friday.